Welcome to a video on the coronavirus. My name is Jeff Parent. I teach math at Open Community College. For years, I've shown my students this video. It's a Prudential experiment trying to induce people to invest for their retirement.
Let it grow over time.
But the really cool thing is just how big that last
retirement
domino
challenge
is. Wow.
Might not seem so big
It's
after
amazing.
all.
In fact, it was a world record. If I recall right, it weighed over 2 tons and it measured just over 30 feet. So it was a real whopper. Now, what does that have to do with the coronavirus? Well, what you saw there was an example of exponential growth. And we're seeing that with the spread of the coronavirus. So here's the number of cases in Michigan. So just over 2.5 weeks ago, today is March 27th, we had 0 cases in Michigan, and then 2, and then 2 again, and then 12. And look at it since then. So today is March 27th, and the number of reported cases is 3,657. Wow, that's a lot. We can model that mathematically. And let's take a look at that graph. Of course, you can see it here to the right, but let's actually connect it with a nice smooth continuous function. And I think you can see why people are worried. The number of cases is taking off. So let's do a little bit of math here. So for my college algebra students, you can take a look at this function. And in particular, right here, the 0.2677, that's the growth rate. And so if you do a little bit of work with that, you can figure out that this really means that the number of cases of coronavirus in Michigan is doubling a little bit faster than every 2.5 days. Wow, that's really fast. Let's go back and take a look at some more of the math. For my calculus students, we can take a look at the slope of the tangent line, or the equation of the tangent line, and that's modeled for us here. And even if you're not in calculus, you can appreciate that the tangent line is a line that just touches the function at one point and gives you a sense of how fast the function is increasing at that point. And so when we look at the tangent line for various places along this curve, then the thing that we want to ask ourselves is, what's the slope of the tangent line? And in particular, f prime of 16 tells us the slope of that tangent line is about 771, call it 772. And what that's telling us is how many new cases we can expect on day 16. That's how fast this function is changing. And that's huge. That's almost 800 more people getting the virus today. For my trig students, I love you, but I'm sorry I got nothing for you in this particular video. We'll do another one for you later. So the big thing about this is that you always hear is social distancing. Well, why engage in that? Well, let's take a look at what happens when you don't engage in social distancing. So this is a simulation. You can run it yourself. I'll put the link in the notes for this video. This is the spread of the virus in a town about the size of Whittier, Alaska, a population of 200. You can see that the number of sick people all of a sudden just really balloons. And if you're not careful, it can overwhelm your healthcare system. Now, eventually, people are going to get better. Things will calm down a little bit, but that's a steep curve, and that's a big problem for our healthcare industry. So what can we do about that? Well, early on in this epidemic, the Trump administration did something good, which was to put a ban on travel from China. But all that did was it shifted when we experienced that big peak. Unfortunately, it wasn't followed up with enough masks and enough equipment, enough testing and stuff like that. And if this line represents the number of people that we can hold in our healthcare system, then you can see that we're going to overwhelm our healthcare system at some point. These graphs here are just for demonstration purposes. They're not necessarily supposed to be actually accurate in terms of numbers, but they're giving you a sense of what happens here. Now, the idea behind social distancing is we're going to delay the onset of that big peak and flatten it out. So this is what we hope to achieve if we can maintain some social distance. We're going to delay it, spread it out, and flatten it. Flatten the curve. We want to delay and spread out that peak so that the peak experienced by our hospitals isn't going to be more than their capacity. And what we've found so far by the experience of other countries is that countries where we don't exceed hospital capacity, that the death rate is much less than hospitals that get overwhelmed, like in Iran. So let's take a look at another simulation. This time we're going to simulate the outbreak where people are really locked down, like they did in China. So here, only 1 out of 8 people is free to move. The rest of them are locked in place. And we can see that, yeah, it is going to pick up a little bit in terms of the number of sick people, but it's doing so at a much slower rate. And you're not going to experience the big peak that you did earlier with people free to move about any way they want. Eventually, some people are going to get better as time goes on. Yeah, there are people that are going to get sick. And when you do this simulation, you're going to get something different. But what you're seeing is a much flatter curve, something that the healthcare system can handle. And hopefully, you're going to protect lives by doing this. Now, there's a little bit more that you should know about the numbers that you're getting, about the numbers of cases that they report. You might say, hey, great, I know how many cases are in Michigan. You know, there's 9 or 10 million people in our state and 3,000 are sick. But that number doesn't quite tell the story. With the benefit of hindsight, let's take a look at the numbers that we experienced in China. So this is in Hubei province, which is where Wuhan is, which is where this all started. And this is analysis done by Tomas Pueyo. So these aren't my own analysis, but let me try and give you a quick version or quick summary of the important things to note here. So what you want to look at is the number of new cases diagnosed each day, and that's these yellow bars. So, well, what's the green bars? The green bars are the true number of cases, and they diagnose that by looking at things in hindsight. So they asked somebody who caught the disease here, well, when did you first experience symptoms? Oh, well, about 10 days ago. So there's a delay between when they first experience symptoms and when they get diagnosed. And so these green bars represent how many people actually had the disease that day, given the benefit of hindsight. And we don't quite have that yet because we haven't experienced the disease as long. But what this is saying is that there's a huge disparity between the number of people that are diagnosed and the numbers that probably have it. And so it might be a lot worse than we realize, especially given that we don't have sufficient testing here in the United States to actually diagnose everyone properly. One of my students has symptoms, but she says she doesn't meet the threshold for being tested. So we do have a problem here. Well, all I'm saying is take a look what happens when you start locking things down. This is when China started locking things down, and pretty soon, look what happens. Now, they did a really good job of locking things down. So we've got to do an equally good job of locking things down. Stay in place. Don't go out, don't socialize with friends. Keep your social contact, keep your social distance, because people are counting on you. These are nurses at Brigham and Women's Hospital in Boston, and their message to you is one that you should take to heart. We stay at work for you. Please stay at home for us. They're putting their lives on the line. They're working really, really hard. They've got families and friends just like you do. So please help them by staying home. Now, if you enjoyed this video, found it useful or interesting, please like it, share it, and maybe this video will go exponential. Thanks.